This is Chemistry 2, Unit 1, Lesson 2, Video 2. So we are going to start looking at different properties of liquids. And we're going to talk about the intermolecular forces and how they create these properties and how they affect them. So the first property that we're going to look at is viscosity. And you might have heard this term before. It is a resistance to flow. So we know that liquids flow. Some liquids flow better than others. So in order to flow, particles must be able to move past one another easier. So in order to flow, the particles that make up the liquid must be able to move past one another. So if you think about it, something that's really small is going to be able to move past other molecules that are small easier than something that's really big or really has a lot of branches. And also, if the intermolecular forces are attracting different molecules, they're not going to be able to move past one another easily. It's going to be more sticky. So if you want to think of it like that. So if we increase the intermolecular forces between the particles, we increase the viscosity. If we increase particle size, so we can use formula mass for that, we can increase the viscosity. So if we have something like C5H12 versus C20H42, this one is going to be much more viscous than this one. This is pentane. This is a liquid at room temperature. As the particle sizes get bigger, C20H42, which is called icosane, is going to be more solid. So we end up increasing the viscosity so much that it turns into a solid. The other thing that can affect viscosity is temperature. And if you think about a liquid like honey or maple syrup, if you heat that up, it flows a lot better. If you cool it down, it slows down. That's because if you increase the temperature, you increase the speed of those molecules, which means that the intermolecular forces are not going to be able to hold on as much because you're increasing the speed, you increase the distance between the molecules. So this tends to decrease the effectiveness of the intermolecular forces and decreases viscosity. And this comes into play with a lot of different substances. We used honey as an example, but this also plays into effect with different types of motor oil. The higher the temperature, it gets more liquid-like. It flows a lot easier, which can be good. When things cool down, it gets clumpy. So that could be bad. So there's different ratings, different viscosity ratings. Antifreeze works the same way. You can measure the viscosity of things. The second one that we're going to look at is surface tension. And surface tension is at the surface of a liquid, and it's a measure of the inward forces that must be overcome in order to expand the surface of a liquid. So at the surface of a liquid, if we have a container that has a liquid in it, there are no forces of attraction really between the air molecules and the liquid molecules. So the only force of attraction the water or the liquid would have would be to the other molecules of liquid. So this is a measure of the inward forces that must be overcome in order to expand this surface, so to move the surface. So some things have more surface tension than others. So these surface molecules are only attracted to those below and pulls the molecules downward a little bit. Which tends to decrease the surface area. So it contracts everything down a little bit on the surface. And it almost forms a skin. And certain animals rely on that they can actually walk on the surface. If you've ever seen those little water bugs that look like they're floating on water, they're actually using the surface tension of water, because water has a high surface tension, and they spread out their weight, they distribute their weight over the surface of the water, and the force that's pushing downward is not great enough to overcome the surface tension, so they can actually walk on the surface of the water. So again, the stronger the intermolecular forces for this, the higher the surface tension. So water, which has a high surface tension compared to other things, is because it has hydrogen bonding. So if we compare water to maybe carbon tetrachloride, which just has dispersion forces, it would not have a high surface tension. And that's going to help with evaporation and different things that we talk about also.